In descriptive set theory, Wadge degrees are levels of complexity for sets of rails. Sets are compared by continuous reductions. The Wadge hierarchy is the structure of Wadge degrees. Wadge degrees. Suppose an a subsets of Bayer space omega is Wadge reducible to or W if there is a continuous function on omega with the Wadge order is the pre-order or quasi-order on the subsets of Bayer space. Equivalence classes of sets under this pre-order are called Wadge degrees. The degree of a set is denoted by W. The set of Wadge degrees ordered by the Wadge order is called the Wadge hierarchy. Properties of Wadge degrees include their consistency with measures of complexity stated in terms of definability. For example, if W(n) is a countable intersection of open sets, then so is. The same works for all levels of the Borel hierarchy and the difference hierarchy. The Wadge hierarchy plays an important role in models of the axiom of determinacy. Wadge and Lipschitz games. The Wadge game is a simple infinite game discovered by William Wadge. It is used to investigate the notion of continuous reduction for subsets of Bayer space. Wadge had analyzed the structure of the Wadge hierarchy for Bayer space with games by 1972, but published these results only much later in his PhD thesis. In the Wadge game, player I and player 2 each in turn play integers which may depend on those played before. The outcome of the game is determined by checking whether the sequences X and Y generated by players I and 2 are contained in the sets A and B, respectively. Player 2 wins if the outcome is the same for both players, i.e., is in if and only if is in. Player I wins if the outcome is different. Sometimes this is also called the Lipschitz game, and the variant where player 2 has the option to pass is called the Wadge game. Suppose for a moment that the game is determined. If player I has a winning strategy, then this defines a continuous map reducing to the complementive. And if on the other hand player 2 has a winning strategy, then you have a reduction of 2. For example, suppose that player 2 has a winning strategy. This defines A as a continuous map F with the property that X is in if and only if F is in. Wadge's lemma states that under the axiom of determinacy, for any two subsets of Bayer space, W or W omega, the assertion that the Wadge lemma holds for sets in gamma is the semi-linear ordering principle for gamma or SLO. Any semi-linear order defines a linear order on the equivalence classes modulo complements. Wadge's lemma can be applied locally to any point class gamma, for example the Borel sets, delta 1n sets, sigma 1n sets, or pi 1n sets. It follows from determinacy of differences of sets in gamma. Since Borel determinacy is proved in ZFC implies Wadge's lemma for Borel sets. Structure of the Wadge hierarchy. Martin and Monk proved in 1973 that AD implies the Wadge order for Bayer space is well-founded. Hence under AD, the Wadge classes modulo complements form a well order. The Wadge rank of a set is the order type of a set of Wadge degrees modulo complements strictly below W. The length of the Wadge hierarchy has been shown to be theta. Wadge also proved that the length of the Wadge hierarchy restricted to the Borel sets is phi omega 1 depending on the notation, where phi gamma is the gamma th Veblen function to the base omega 1. As for the Wadge lemma, this holds for any point class gamma, assuming the axiom of determinacy. If we associate with each set the collection of all sets strictly below on the Wadge hierarchy, this forms a point class. Equivalently, for each ordinal alpha theta the collection W alpha of sets which show up before stage alpha is a point class. Conversely, every point class is equal to some alpha. A point class is said to be self-dual if it is closed under complementation. It can be shown that W alpha is self-dual if and only if alpha is either 0, an even successor ordinal, or a limit ordinal of countable cofinality. Other notions of degree. Similar notions of reduction and degree arise by replacing the continuous functions by any class of functions f which contains the identity function, and is closed under composition. Write f if for some function in f. Any such class of functions again determines a preorder on the subsets of Bayer space. Degrees given by Lipschitz functions are called Lipschitz degrees, and degrees from Borel functions Borel-Wadge degrees.